Hello, welcome to the second day. Here today the problem is the end of the chapter problem 2.6. On a winter day, temperature with minus 10 degrees Celsius, which we may have this weekend, you adjust the pressure of your car tires to 1.8 10 to 5 Pascal. What is the pressure in the summer? That's the question. So you have a tire at a certain pressure and temperature. The question is, what happens when you change the temperature? The connection between pressure and temperature for a gas. What do you know about them? Well, yes, ideal gas law, right? The PV equals nRT. Okay, now you can pause here and think for a moment how you could use this equation to solve our problem. Once you have thought about it, you can continue to watch and we can do it together. So let's pause. Okay, first, we need to assume that the air in the tire behaves like ideal gas. Most of the time, this is not a bad assumption. So, okay, basically by assuming that, we say we can apply the ideal gas law to the gas in the tire. Now, if that's the case, what does this PV equals nRT mean for the relationship between the P, pressure, and the temperature? It means when the V and nR remains the same, meaning constant, the P is going to be linearly proportional to T, temperature. So then, let's think about what we have for V and N and R. So for our subject tire here, we are assuming we don't add or lose the amount of air in the tire between the winter time and the summertime. And then we can say our N is constant. Okay, for a good tire, you don't have to add air, you don't lose air. That should be doable. So we can assume that. Lastly, and then we also need to think about R. Well, R is an ideal gas constant whose value is 8.3145 joule per mole per K. So it's by definition a constant value. So then how about V? V is volume. As long as the tire does not really change its shape, the volume of the tire, we can say it should be constant, or it's a good approximation that we say it's a constant. So we can call also V a constant. Given these, we can rearrange this PV equals nRT equation and put all the things that are constant to one side and leave the other things that we are not assuming to be constant on one side. That is the P and T. And one way to do that is to move the V to the right side and move the T to the left side. The left side would be the non-constant values and the right side would be the constant values. So then if we do that, it becomes P divided by T is going to be equal to N times R divided by V. And since this, and this are all constant, this has to be a constant. In other words, if you take the value of V and then divide it by T in any temperature or any pressure, this ratio has to remain constant. Now, let's say the first pressure and temperature as P1 and T1, and the second pressure and temperature as P2 and T2. We can say that P1 over T1 is equal to NR over V, and that should be equal to P2 over T2, right? So since our N is constant, R is constant, V is constant, whether you have at the gas in the tire at one condition or two another condition, the ratio between the P and T should remain the same. Now, since our question is about the pressure in a new condition, let's say second condition, you can rearrange this equation to solve for P2. So basically have the P2 on the left side of the equation and put everything else to the right side. Maybe perhaps you can do that. And actually, to move on further, why don't you, after you do that, why don't you also plug in the numbers and calculate for the P2 with calculator. So, okay, here, let's pause again and do this. Okay, so P2, when we reorganize this equation, is equal to P1 over T1 times T2, correct? And now we just need to plug in our numbers. P1 was equal to 1.8 10 to 5 Pascal. And T1 was minus 10 degrees Celsius. Now, please remember the temperature in the ideal gas law is in kelvins. So in other words, when T is equal to 0, that's the point where PV should go to 0. Don't use the Celsius as is. So we have to convert the Celsius to Kelvin, and which is done by adding 273 to the value of the Celsius like this. So that's our T1. The minus 10 was our T1. And then our T2, 30 degree plus 30 degrees Celsius would be 273 plus 30. Okay, so then you can calculate this. So this is basically 1.5 times 10 to 5 Pascal times this is 303. This is 263. If you do that calculation, the answer should be 2.1 times 10 to 5 Pascal. And please note that the significant figure for this is 2, since we are limited by this significant figure in the pressure. So significant figure in 2. I hope your answer were also correct. Did you get this right? I really hope so. Well, that's it for today. I hope this was a good, short but sweet workout for you. Thanks. See you soon. Bye.